Okay, so let us start solving these problems. The first problem is, so let me write the formula here in front of you. So we have this binomial theorem. Yes, so this we have this theorem, and then in this problem you have this expression to power 6, and now I am asking you which one, find the middle term actually. Of course, this question might be a little bit ambiguous because you know that in principle, when I raise this one to power 2, say, of course, we usually write it in this way. And then if I ask you what is the middle term, you would say 2ab. But if someone writes it in that way, it's not wrong. Yes? That's the same thing. And then I ask you what's the middle term, people say b squared. But in these kinds of questions, this is a standard. When I say the middle term, it means that if you write everything according to the Newton's binomial theorem, assuming that this is A playing the role of A, this is playing the role of B, and write it exactly equal to what is written in this formula, then I'm asking you about the middle term. So that's the, yeah, I think it's natural for us to understand this, even if I haven't mentioned that. Yes?
We also define the midterm as the one where both A and B are raised to the same power.
No, if you talk about A and B, no, because if sometimes we don't have a middle term, but if we have a middle term, might be you are right. Yes, because here, here I have a middle term, so these powers are the same. Yes. Okay. But because these are the things that I don't know exactly, I will solve them case by case. So here I am interested in finding the middle term, but as you said exactly, what is the middle term? Yes. How many terms are there here? No, in general. N plus 1, not n. There are n plus 1 terms. So how many terms are here? There are 7 terms. Yes. So when you say 7 terms, 1, 2, 3, 4, 5, 6, 7. So it is clear that the middle term is the 4th term. Yes. So this question is actually asking you what is the 4th term. And then do you remember this? If I ask you which term is this, is it k, term number k, or what? This is term k plus 1. Yes, that is term k plus 1. So this one is term number k plus 1, because when you put 0, that corresponds to your first term. When you put k equal to 1, that corresponds to your second term. So if I ask you what is this written here, this is not the kth term, this is k plus first term. Yes? So this is tk plus 1, and this is nk, and then I have a to power n minus k, b to power k. Yes? Here in this problem, just compare them. Immediately you see that n is 6. If I ask you what is playing the role of a, square root of x, what is playing the role of b, you need to consider the negative one as well. So this is playing the role of b. Yes? And now what I am supposed to calculate, I am supposed to calculate the 4th term. So what is the meaning? So if I want to calculate the 4th term, what should I choose for k? I should choose k equal to 3. Yes? So it means that k has to be chosen to be 3. And when I put it here, it becomes 3 plus 1. The 4th term is equal to k, which is 3, n, which is 6, a, which is the square root of x to the power of n, which is 6 minus k, and then you have minus 1 over x to the power of k. So that is actually what is wanted in the problem. Is that clear? And then you have to simplify this expression. So for 6, choose 3. How should I calculate? You can calculate whatever you like, but I prefer to write that theorem. I need to write 3 consecutive integers, 6, 5, and 4, and then divide it by 3 factorials. That's it. And then this one is 6 minus 3 is 3, and this is x to the power of 3 over 2. Hopefully you agree with me. Yes? And then this is minus 1 to power 3, so it becomes negative. I bring x to up, it becomes x to the power minus 3. And then let us simplify this. So 3 factorial is 6, and that is gone. So I will left with 20 here, minus 1 here. So it is minus 20. And then I have x to power 3 over 2 minus 3, which becomes x to power minus 3 over 2. So this is the answer to this problem. But because this is a multiple choice question, I need to see that which one is exactly equal to that. So what I can do, I can bring it down. So it becomes minus 20 x to the power of 3 over 2. But this one can be written as what? The second root of x to the power of 3. You see that this is not in the options available, but you see that this can be written as x squared times x. X squared goes out. By the way, is it x? Because you know that in principle, is this formula correct or not? Is this formula correct or not? Yes or no?
Yes.
Yes or no?
Yes.
No. This formula is not correct. Why? Because I told you several times that this should be absolute value. Be careful about that. If you have even, it has to be. This is not just fancy thing, yes? Because if I ask you what is this number, what is the answer to this, by the way? It is definitely 2, because minus 2 to the power 2 is 4, square root of 4 is 2. But if you naively say that, okay, I just get rid of this, what you get is minus 2, which is not correct. Be careful. If you have even root, it has to be a square root. And so why don't I don't put absolute value here? Yes?
No, no, no.
Why? You were close, I think.
No, yes, because square root of
Yeah, a square root of x appears in the problem itself. It means that x is not negative. If it was negative, I was not able to design the problem in the first place. So it is absolute value. There is no exceptions for the rules of mathematics. It's not like chemistry, you know. In chemistry, you learn a rule, but then you learn a lot of exceptions for that. This doesn't work here, this doesn't work there. Yes, I don't know. Have you faced the same thing in chemistry? Yeah, and the reason is that because, of course, none of them are exceptions. If you study quantum mechanics, you see that there are reasons for that. Okay, but intuitively, if they want to teach you chemistry without knowing a lot of mathematics, then they have to teach you in that way. Okay, but then, yes, yes, I am recording it with iPad. Yeah. So here, in principle, it has to be absolute value, but because of the design of the problem, I know that x is positive. When x is positive, I don't need absolute value because absolute value of positive numbers are equal to themselves. So this is why we don't put absolute value. And I think I have given you one of these options, yes, for this. Okay, so this is one I would consider it simple question. It's not a hard question. This thing you need to know what to do at this level. Okay. Another problem, I don't know which one was the second one in your list. Yes, which one is that? Use the binomial to prove this one. Okay, I don't know how many of you, do you remember if I have a natural number, so what is this sum? Do you remember? This is a famous sum in combinatorics. I want you to remember it. But we talked about this in a different way before. So what is the answer? Do you know? 2 to the power of n. So why is that? Do you remember the previous method that we solved this? Yes?
we imagine like a binary number of ones and zeros, and then we select how many ones we want to have, and then if it's one, like how many ones we want to have, and if it's one, well, then it's n selects one, and if it's
No, because in binary codes, I don't know if I talked about binary codes, but by binary codes usually permute. They are so this binary code is different from this binary code. Yes.
yes,
So
we want to select how many places for
Okay.
zeros.
Yeah, okay. Yeah. So the way that I was looking at this problem, anyone, do you remember? You wanted to say something?
We thought of it like using
Set theory, the subsets, yes? So if I give you a set consisting of n elements, do you remember? On the one hand, if I ask you what are the possible what is the number of possible all possible subsets of this, we know that this is 2 to power n, just what by simple product rule. And then on the other hand, these subsets are those subsets without elements, the empty set with one element, with two elements, up to with n elements. So if I calculate all of them and add them, definitely it becomes the total number of subsets. So that's a very strong combinatorial argument that why this sum should be equal to 2 power n. And that's a very powerful one, actually. But now, do you see that how can I reprove this again using the binomial theorem? The reason that I'm bringing this up, because then you see a lot of opportunities in front of you to talk about different series using the binomial theorem. How can I use yes?
We use the sum, but we have a and b both equal to 1.
1, exactly. Is that right? So because this formula is valid for natural numbers n, but any choices of a and b that you like from the set of real numbers. So you need to be creative to see what choices of a and b is appropriate for the problem at hand. Yes? This is up to you. It's not something that I can teach you how to find them, but for these simple ones, it is not that hard. So you see that in that formula, what I can do, this formula in the binomial theorem formula, I can choose a equals to b equals to 1. Agree? So this formula tells me that 1 plus 1 to power n is equal to the sigma k goes from 0 to n choose k. Instead of a, I put 1 to power n minus k, times instead of b, I put 1 to power k. Yes, that is the formula, binomial formula, but I have replaced a and b with 1. But 1 plus 1 to power n is definitely 2 to power n. But what is this one? 1 to any power is 1, 1 to any power is 1. So everything here is just 1. So what is left for me is just this sigma. And if I open this sigma, it means that I put 0 first, n, I put 1, I put 2, and I continue until the very last one. And then what I have to do, I have to add them because of sigma. So it means that I get my answer. So this is a very nice way to be able to solve some particular series, these kind of sums in combinatorics. Okay, but let us talk about the next one. The next one, we want to show this. Of course, it is a little bit ambiguous. I don't know if you understand what I wrote there. 0n, 2n, 4n, and then continue, or 1n, n choose 3, n choose 5, continue, and then I want to show that this is 2 to the power of n minus 1. What I mean by this, I don't mean that up to infinity, because first of all, it cannot go up to infinity, because in this symbol, you know that this number shouldn't exceed this number on top. Yes, this is the number of choices. I have n people, I want to choose 4 of them. If I have only 2 people, I cannot choose 4 of them. Yes. So when this symbol makes sense, it means that this number is smaller than that one. So this means that you continue until the very last step that this is meaningful. Yes. For example, if n is 5, then how many terms you see here? I can write 0, 5 plus 1. Plus 2, 5 plus what? 4, 5. This is the last one, because if I jump 2, it becomes 6, 5. It is meaningless. This claims that this is equal to, if you write this, 1, 5, 3, 5, I don't know, 5, 5. And the answer to both of them is 2 to the power of what? 4. N minus 1, 5 minus 1. So this is the claim. This is not a coincidence only for 5. This will work for 6, for 5, for everything. Yes? So in principle, can you interpret this in the language of subsets? What is the meaning of that? Forget about proof. Just assume that this is correct. Interpret it in words. What is the consequence of this for a subset? Anyone else? Yes? No, what contains the same?
There are subsets. Let me start. Could you print this using a rule?
No, what's the interpretation? How do you read it in words? Yes?
It's like you have all the subsets with even number of elements.
Is equal to the sum of all subsets with odd number of elements. Yes? This is the subset containing 0 element. This is the number of subsets containing 2 elements. This is the number of subsets containing 4 elements out of a 5-element set. Yes? And this is so it means that this is the total number of subsets including even elements. And this is this number of subsets including odd elements. So this is telling you the total number of subsets including even elements is definitely equal to the total number of subsets including odd elements. And of course, this is trivial now because the total number of the elements is supposed to be 2 to the power of 5. So according to this equality, then half of them should be of this type, half of them should be of that type. Yes? But why this is correct? Yes, there are two ways of thinking about that. Combinatorial argument in this case is a little bit complicated, but I want you to use the binomial theorem for proving this. Any ideas? Yes, Alex?
I mean, couldn't you reverse the order and then use the fact that n combines with n minus r is the same as n combined with r?
So
We reverse it and then
so what do you mean by, yes, this one and this one are equal.
yeah, and we can prove that they're equal by reversing the order.
No, but how do you connect this one with that one?
Because 5 combines 3 is the same value as 5 combines 2,
Yes,
but with using the rule that we proved
yes,
earlier.
yeah, exactly. That's one way. Yeah, so this is not binomial theorem. You are right. You are saying that we learned before that if I have n r, this is equal to n minus r. This is an extremely important rule for these choose numbers. So Alex is saying that, okay, 5, if I ask you what is 0 and 5, you can connect this one with that one. Yes, they are the same. And 5, 2 is equal to that one. And then 5, 4 is equal to that one. So the sum of them are equal, is definitely equal to that one. But if I want to use the binomial theorem, do you have any idea how to use it? Use the binomial theorem to prove it? So let me rewrite the binomial formula in front of your eyes. So let me expand this as you are thinking. I'm coming to you. So 0n a to the n. Yes. The next one is 1n a n minus 1b. The next one is n2 a n minus 2b2. And then let me write the next one as well. Then it continues until, let me write the last one here. It is nn b to the n. The previous one is nn minus 1, a to a bn minus 1, and the previous one is nn minus 2, a2 bn minus 2. Yes? So it continues up to this. So this is the expansion, agree? I have written some terms in front of your eyes so that you can feel it better. This is the same sigma. I have opened it. I have written some terms from the beginning and some terms from the end. Okay, and now can you see that what choices of A and B this time will work? In the previous problem, you told me choose A equal to 1, B equal to 1. Yes, it worked. But can you see Any other choice for A and B so that it gives rise to this equality in general? Very, very simple numbers.
1 and minus
1 and minus 1, yes? So you choose A equal to 1 and B equal to minus 1, yes? A equals to 1, B equals to minus 1. Why this is good? What happens on the left-hand side? It becomes 0. Because 1 plus minus 1 to power n is 0. On the right-hand side, I will have 0, n, but A has been chosen to be 1. So 1 to power n is just nothing. What happens for the next term? The next term is n1. A has been chosen equal to 1, so you don't need to be worried about A's at all because that's 1. But you have to be careful about B's because sometimes the power of B is even, sometimes it is odd, yes? So here I have 1B and B is negative, so this sign becomes negative. Agree? And the next one, what happens? For the next one, this becomes 2n. That's it. And the next one becomes negative. Agree? And then this continues until, for example, here. What happens here? What should I write there? Can you tell me? What should I write for the very last one? Minus 1 to power n. That's not under my control. It depends to the, this is called parity. When you say parity, it means evenness or oddness. So it depends to the parity of this n. So it means that at the very end, I will face something like this. But what is the previous one? The previous one is minus 1 to power n minus 1, and then I have n minus 1. And then the whole expression is equal to 0. So you see that the ones with even ones are positive, so I keep them on this side. The one coming with odd ones are negative, so I move them to the right. They become positive, yes? So it means that the sum of the even ones is equal to the sum of the odd ones. Is that understandable? And of course, because the total of the total number, the total sum is 2 to power n, these two groups are equal, and the sum of both of them is this one, so each one of them should be half of 2 to power n, which is 2 to power n minus 1. Okay, is that clear? Okay, what is the next question? The next question, I have asked you to find this sum without calculator, yes? So I have written this if I am right. So 10 choose 0 minus 3 times 10 choose 1 plus 3 to power 2, 10 choose 2, and then minus up to plus 3 to power 10, 10 choose 10. I am asking you to calculate this without the calculator. And of course, I can increase this number to bigger numbers. So don't start doing them one by one. So what should I do now? Did you find a way to do it? You have some experience now, probably. At least you have some ideas, yes? These are the questions related to the binomial theorem. So at least you know what should be the method, yes? What is the method? This is not 16, this is 10, yes? All of them are 10. Okay, so what is the method? What is the strategy at least? Yes? No? Yes, do you have any idea?
A equals 2 minus 1 and B to 3.
So I did not understand. A what?
A equals 2 minus 1 and
Uh-huh.
B to 3.
I think so. Yes, but what about n? Because there is no n in this problem. If you don't choose anything for n, n will remain in the problem, but I want to get rid of n. 10, yes, this is natural. If it is going to work using this formula, then probably n should be chosen 10, but let us see that which one is correct. A is -1. This you need to be careful, but you are completely on the right track. We need to do some trial and error. Okay, so I would, can you write, by the way, can you write this question mark in the form of a sigma for me? Might be that's also one way to look at it. So you see, uh, what is the power of 3 here, which doesn't appear because all of them have a power of 3 except this one. What is the power of 3 there? 0. So because if you want to write in sigma form, you need to have a pattern. So you see that you have a choose number. The top number is 10, but the lower number is 0, 1, 2, up to 10. So you put a k here and you change k going from 0 to 10. So you are making this one by one, correct? Yes. So this is actually, this part is now taking care of this. But you see that you have a power of 3. Okay. Do you think this is a good choice to put here? That is good, because if I put 0, it will generate the first time. If I put 1, it gives me 1, 3. I need it here. If I put k equal to 2, it gives me 2 3s. That's also good. But I have this alternating sign from positive to negative, from negative to positive. So it is clear that I need to include a negative sign here. This will take care of that minus sign that I need. Why? Because if k is even, this minus sign does not appear. But if k becomes odd, then this minus sign appears. Is that understandable? So by putting a minus sign inside, so I think this is a better choice. Instead of putting a equal to -1, b equal to 3, I think it's better to put b equal to, or might be you are right, I don't know. Because this is extremely important to see. And if I want to write it in that way, this should play this role of this one. Okay, that's correct. So let me write it the other. Do you agree that this sum is exactly this question mark? But this is not exactly in that form, but there are some minor things that I need to do. By comparing this one with that sum, I see that this is playing the role of the second part. So, and there is no first part. There is no first part means that I have to choose a equal to 1. So I think this is the answer. We choose a equal to 1, but b equal to -3. Okay, so then it becomes times. So then I can write it in this way. Sigma k goes from 0 to 10. Choose 10, choose k. Then I would write, 1 to the power of 10 minus k times -3 to power k. What I want to convince you, I want you to convince you what I have written here, even though it is a little bit of a strange way of writing, but this is exactly my question mark. The reason that I put it in this form, because it is immediately comparable to the Newton's formula. And then if you compare this one with that one, you immediately realize the answer to this is what? Is a, which is 1, plus b, which is -3, to power 10. Yes? And 1 minus 3 is -2 to power 10. And then this becomes 1024. 1024. So the answer to that problem is 1024. Okay? And I think this is a very simple piece of code that you can check. I don't know. Are these languages that you are working capable of putting this directly, or you have to write a code for them? Okay, so the good point about Wolfram language is that all of them are built-in functions. So it's more appropriate for mathematical programming. So I don't know, in other languages you might need to write a code for this piece or okay, yeah. What about factorial? Is factorial included?
It's never used so
Yeah.
in normal programming.
Okay.
But I mean that's also a trivial function, right?
Yeah. Yes. Yes, yes, yes. So is that understandable here? So you see, this is also one way to look at these series. Yes, finding the sum of series is quite interesting problems. Okay, and I think there is one problem left. Yes, but we don't have that much time. So two problems left. So let me stop here. Especially the second one, I gave it as an A-level question in the last year exam. So you can think about this. Uh, but I don't know, this year we are making the questions unreasonably simpler. I don't know why. Yes, but yeah. Anyway, so these two problems are left, so you don't need to get bored in the Easter break. You have a lot of things to work on. Okay, you can work on these two problems when you are bored. Yes. Usually, when I am depressed, I start doing some integrations. I feel relaxed. Some sub series. This is one of the favorite subjects to try to find the sum of some series. You need to be creative to find those things. Okay. Anyway, I hope that you have a great holidays in France. See you, I don't know, in 10 days or something. Yeah, it's more or less 10 days, yes. Yeah, it's quite a lot. Don't waste it, yes. Yeah. Thank you. Bye.